Hold him, yeah.
So, how would I build a peer-to-peer Twitter system? Because that's a very simple case. We figured out. If I understand Twitter correctly, you publish tweets on your name, and you can also respond to someone else's tweets by making a tweet that is kind of linked to his tweet, right?
Mm-hmm.
Yeah. That's what Twitter is about.
Yeah. And following.
Someone can, of course, follow all of your tweets.
One more element is the timeline, unless.
Yeah, but that's following.
Okay.
So that's kind of the basic functions of a Twitter system.
Yeah, you can search as well, of course.
Ah, okay. Search is less to do, but okay. Let's skip that for now. And get the basic functions. You can search what you're following. Or you can search the
You can search on like hashtags or like.
You've got hashtags as well.
Ah, okay.
Hashtag is just.
Okay.
It doesn't actually work that well.
No, it sucks.
We could rebuild it now.
We're not talking about Twitter.
We should fix it and then make that big.
Where you can search.
Okay, so let's look at this.
First of all, come out with an over-opinionated
Fix it first, peer-to-peer second.
First of all,
Fix
each
first,
user
key second.
on the peer-to-peer Twitter needs to have a public key pair.
Hands off them.
So his identity is actually not really his name, it's his public key that is his identity.
Mm-hmm.
And he of course signs his name to that. Everything he publishes signs for that, so we know who's publishing it. And his node, he runs his Twitters and they get stored in his node, for starters, of course. And initially that's all there is. It's not pushed out into the network. So only when he's online it's there, for starters. But someone following him, some other node, so let's have one node here. For some reason finds him, for instance, knows his name or searches some of the content. We can put some of the tags or something. He can have some subject tags that that gets published into the distributed hashtag.
Oh.
So if someone looking at, I want to know more about peer-to-peer, you might find peer-conf, because peer-conf is tagged with some names like peer-to-peer and stuff like that. So we'll find this Twitter stream, what do you call it? The tweet stream, yeah. And he will simply download, well, the last month or whatever it is, from this node and store a copy of it. So now this node has a copy of the stream, of all the tweets. And they are signed by the originator, of course.
Yeah.
And then anyone else that also want to follow these tweets can download it from, well, this one will also publish on the distributed hashtag that I now have these tweets.
Mm-hmm.
And that means that anyone else that want to get those tweets can get them from the originator if he's still online, or from one of his followers. So after a while, if you have a bunch of followers, there will be a whole bunch of computers that has a copy of your tweets. Mm-hmm. And in that way, any new followers can get a copy from them even if you're not online anymore. So that might even survive for a long time after you've gone and dead or anything, if people still want to read your own tweets.
This is totally viable because a tweet is only 140 characters and the average person only tweets like 12,000, 20,000 tweets.
Yeah. So these ones effectively become a file sharing swarm, if you think of in file sharing terms. Mm-hmm. They will know about each other. They don't really need to stay connected because perhaps you're following too many. But they will all be in the DHT. You can find them or whatever search system we use. So they can find each other and occasionally connect to each other and compare and see if do you got any new tweets from him? No? Okay, drop the connection. So when he writes a new tweet, he will connect to several of them and push it to them because he knows they want it.
You can do that with a simple hash, I guess. Is the same hash as I have, or is it updated? Or
you know how you synchronize them.
Mm-hmm.
Yeah, it's his ID plus the message number. So it's again as before. As when you do that kind of broadcasting within the mini groups, ID and message number.
This is where I fell asleep before.
So does this number incremental keep?
Yeah, this node just increments it and signs every message, of course.
Okay, so it always goes up.
So when is?
I dreamt this. I dreamt this bit.
Oh, okay. So if he makes a new tweet, he will connect to some of his friends that he can find them in this hash table because he might even know he might have received a new follower while he was offline, and that follower will insert himself in this hash table, telling I'm a follower of him. So he will find his followers in the hash table, and so he will connect to some of them, or well, if there are too many, we perhaps shouldn't connect to all of them. and he will tell him I have a new message, do you want it? So he just sends this. Well, the first few perhaps you can just push it immediately because they obviously can't have a copy of it yet. But they will push it to them, and they will then, as usual, occasionally connect to each other and check, do you have anything new? And they will compare. And this one, for instance, this one gets it, and they compare and say, oh, I have a high number, then you have it, and you can have it. So this is kind of like a slow broadcasting swarm that doesn't stay connected all the time. So this is actually kind of slow broadcasting, a really slow one.
And it's fine that you always connect to anyone, like, because on Twitter, like, if you have more than 1,000, if you're following more than 1,000 people, you're probably a spammer or something, or you're probably not real. Because most people try to keep their following graph pretty small. Because you can't really consume any more than 1,000 people.
Oh, that's crazy. Yeah.
Information.
No, you can't.
No, you can't.
You can't. I can.
Why have an account then?
You're not the normal person.
It's your full-time job?
It's part of my job, so I have time, yes.
Okay, yeah, I mean, if it's your
not
job...
done yet, by the way. We're not done with that one. But
Say that you want to look up your followers in the distributed hashtag. What's the mechanism when you get to your section of the hashtag?
Yeah,
what's the mechanism for discovering all of the nodes within that hashtag?
okay. Yeah, we haven't talked about that. That's about the hashtag, but that's a good question. This node creates a database field, really.
Yes.
It's a database field, but we usually call it a message because it gets sent somewhere else. So it's a database field that contains the address of the node, as usual, IP number, port number, hash of public key, and version number, as you call it, that hash of the ability list. And also, in this case, a small string that means I'm follower of that one. And that, it then traverses down this hash table to the node that has the address closest to that name. The hash of his name, really. The hash of his public key in this case. And that node that is closest, you give that node this little database field that you created. And you also store it in some of the neighbor nodes.
So he ends up collecting a bunch of, all of the new followers of the node.
Yeah. Good. So that's in this case kind of a single point of failure.
But the first guy can look up his followers quickly. He only needs to request a few nodes.
When this one looks up his followers, so we just go down to that node and give me everyone that matches, all database field that matches this key. And he gets all those little messages that I'm a follower.
You could even say, give me all of the new followers since last time.
If you have a timestamp on them, you can do that. Yeah, of course you can. That might be one to simplify it. Also for these ones, they will not new.
Because Twitter has important real-time aspect. We have it hasn't you don't.
Yeah, okay, it doesn't have to be that fast.
Yeah, a few minutes though.
Okay, yeah. So these ones should, these ones should be connected in an actual running swarm, or you could do it with UDP and have connections. But also TCP is really nice. You don't have to send packages very, very rarely to keep TCP alive. I don't know how long it can wait. I think it went for a very long time without any overhead.
There's also, I think, with Twitter, quite a strong probability that you will end up with mutual followers for quite a lot.
You can reuse connections then.
Yeah. And you'll have people that you follow that follow you back, or that follow someone else that you follow.
Yeah.
Quite likely.
Also, one thing you can know, since here you have the whole list of followers, you don't have to connect them really as well. You can random walk them and share update messages.
What happens when you delete something? When you delete a tweet?
Well, we could do that.
It's a new message. It has to be a new message that tells everyone to delete the old message.
Yeah. You create a message that tells to delete the other message and then broadcast it over this swarm. And eventually all of them will have deleted it, hopefully, and then that delete message eventually will be thrown away.
Of course, you have to trust them that they will delete it. So make sure you don't tweak your password.
You trust all your DFTs, right?
They say you want to unfollow somebody. Do you just start rejecting messages? If somebody finds you and says, "Oh, you're part of the following of this person," you unfollow.
Unfollow. Well, yeah, of course. All of these database fields then should be signed. Because if you want to unfollow, want to guarantee that, well, you don't sign them, sorry. That's an optimization there. You could, of course, sign your unfollowing message with a normal public key cryptography. So then you can contact that node with a new message signed by you that I'm not following anymore. That's one way to do it. But those signatures are a bit clumsy. So another way, because that node then has to know your public key and stuff like that. Instead, you just put in a random number. No, sorry, you create a random number, keep that secret and hashes it. So you put a hash in the end of the message, and no one else knows the random number to create the hash. And the day you want to delete it, you just send the delete message with the actual random number. And because that can be as little as, well,
that's
20 bytes.
really good.
Yeah. So you tell them, I want to delete it, and the only thing that you use that random for is for the delete message. And then everyone knows, if they get that random number, then you've proven that you want to delete it.
That's
So, yeah.
really nice.
Okay,
It's in
so
less space, and
So what if, like, okay, so there's 3 nodes in a network, and one node is, you know, people are connecting to it, other people who aren't following the other 2 nodes, just they're connecting to that one node and they're seeing the tweets. And how does that one node at the bottom prove that the tweets were actually made by the one at the top instead of faking it?
Because all the tweets should be signed with public key cryptography from that node. So the tweet itself, each tweet is signed with his.
But can't that node just insert like?
No, because it's signed. You don't know how a cryptographic signature works, perhaps.
Well, no. I mean, I think I do. But what if I just create a tweet that has the same username and put the picture there, and then just say this is this user?
Yeah, because anyone connecting that.
How do you stop? Because most
usernames aren't unique. Like public keys are the only unique.
So
thing.
most users.
Oh, you're saying you shouldn't have a username. You're saying you should always have the.
Well, you can't.
No,
So
map to
you
a
can't.
unique key.
In distributed fashion, you can't guarantee unique usernames.
But you
You
can
could
guarantee
say,
unique
you could say this is my username, but it's not.
Okay, so you're saying that okay, so you wouldn't use a username
But-
in this case.
Actually,
you can
that too.
display it.
Yeah, you can display it
As a display name. Okay, I see what you're saying. So that answers my question, because if it was just the username, then it wouldn't work.
Yeah, right.
Yeah.
You have to have a public key. So your actual identity is a hash of the public key. That's your actual user identity.
Although you could use a blockchain method like Bitcoin for guaranteeing that everyone has unique.
Guarantee uniqueness?
Oh yeah.
Yeah.
So that's messy.
But it is messy. But
It's hard to maintain, but yeah.
you
you
could
could
We have
do that, yeah.
another approach.
you would have to replicate all
And
of
your
the-
tweet could just have a field on it that was like display name or something.
Actually, what some systems do today is you have a username, like
And your client could keep track of the
David.
the private keys, or the
And
public
he
keys
also has,
that are responsible for each tweet.
and so on. And you have also this hash of your public key. So you display both of them, perhaps just part of that. And if you try to connect, or you get it, for instance, a response tweet from another David, your application will tell you, this is not the same David that you usually are looking at. This is another David. You want to add him? So you get you're warned when you get a collision, and you also have the option to add a comment or something, so you can tell the parts of David from Sweden.
Yeah, because on Twitter you have like a billion people named David, and they all have like the default icons, and it's like what?
Yeah, but you will get a warning that says another day there, and then you can perhaps look at his first tweet. He seems to be talking about add a comment here or something.
Right.
So that's how some networks handle it. But
So,
anyway,
if you really want to connect to David, you need to have his public key. Like,
yeah, to be sure that it's, pretty sure that you look at the right one. But but simpler but not as secure choice is to connect, check where David's are, check their Twitters, and check who seems to be the right one. So if someone is really faking you, of course, then you're in trouble. But you can often just check the message and that's the peer-to-peer David I'm looking for. The other ones are there too. He's talking about Gothberg, so that's not him.
yeah, but if there are 2 million Davids or 1 million
Yeah,
Davids,
then it's
like,
better. But then it's my fault by choosing a too stupid username.
Oh, it's your parents' fault in this case.
Well, one of the nice things about Twitter is that
it's your parents' fault.
Yeah, my parents.
Not your fault.
well, one of the nice things about Twitter is that you can't pick a name like David. If somebody's already got it, it's gone. You can't make it.
Yeah.
Actually, some Twitter businesses have anti-collision function, but that only works to a certain size, because what you simply do, you first, let's see, how do you do that? The trivial approach is simply check all names there are, and then publish your own name connected to a public key, but that doesn't work, because at this exact moment you do that, someone can see that and do his own publishing of David and collide with me.
Mm-hmm.
So usually we first publish some kind of hash of it and spread that, and then we tell what that is the hash of.
Mm-hmm.
So then someone can just block us and pretend to have decided to hash the name David.
So probably the best way, I mean, it's simplest just not to allow unique usernames.
The problem is, that system that checks if it's unique, it means you have to see all username, and when the system grows too large, you can't handle it anymore, then you get flooded. So then it doesn't scale.
Mm.
So unfortunately, there is no good scalable way to follow it. Oh, there is. You can actually insert them in the distributed hash table and check them that way. So
What about
you can check collisions.
A sign up is a one-time process.
Yeah, but the problem is then you have to store the name in the distributed table forever. That becomes a storing the network problem.
Mm-hmm.
And that means someone can flop it with HT by putting it.
They can swap too many names.
Yeah, and they can just flood it with data,
Mm-hmm.
because these nodes are not supposed to store them forever.
Mm-hmm.
Normally you store things for 2 hours and then you dump them if they don't update them.
Mm-hmm.
So actually it's a hard problem, I think, to have unique names in a very, very large peer-to-peer system. So usually we use instead a random name, that is the hash of the
Like by
and then
Your
names
lookups
are allowed
could
to
be on
once
the
I enter
the
a key, you can make sure that
hash.
it's unique,
but
but you don't
when
make
you
sure
initially
that it's
pick a
unique by
username,
checking everything.
that could just be a one-time lookup.
You could perhaps use it first before
Yeah, you can have stuff like that too. But still, just
it's only tech though.
but there are more parts to this one you should think about. If someone comments your tweet, it needs reporting to you that someone commented you, right?
Yeah, because you want to interact back with them.
Yeah,
Eventually.
So,
It doesn't have to be immediate though.
Yeah, that's true.
then he will simply, if you're online, that node can simply tell you, I commented on your tweet. But others should also see that, right?
Yeah.
So simply, this is a swarm. It doesn't matter who you talk to, really. Just that he can only sign the message, but the rest is this is one swarm.
Yeah.
So a node that commented on the tweet simply contacts anyone in the swarm and send them, I tweeted this as a comment.
Right.
And they will distribute it